Hello everyone, welcome to this part 4 video on KSSM Mathematics Form 2 Chapter 1 Patterns and Sequences. So in this video we're going to look at the subtopic 1.3, and in this part we are going to learn how to describe or shows a pattern of a sequence by using numbers, words, and also algebraic expression. So now let's look at example number 1 here. You are given a number sequence. So this is already known as a number sequence. Hence, it must follow a certain pattern. So we want to describe the pattern here. So before that, we try to identify the patterns. As you can see, the numbers are increasing. So if it is increasing, it is either addition or multiplication. So we start off with addition here. From 1 to 5, yeah, we add 4, right? 1 plus 4, you get 5. 5 plus 4, you get 9. 9 plus 4, you get 13. And so on. So now we are going to describe the pattern here by using numbers and words. And actually, you have already learned this part in the part 1 and part 2 videos. Okay, so we go through this as a revision. Numbers, okay, if you want to describe the patterns by using numbers, the pattern is add 4. That's it. You can stop here. And if you want to describe this in words, means we want to write this in words, you can write the pattern, oh sorry, typing error. The pattern for the sequence is add 4 to the previous number. We look at another simple example, example number 2. And as you can see, we have another number sequence, and we need to describe the pattern by using numbers and words. So here, again, the number is increasing. So, okay, 1 plus 7, you get 8. 8 plus 7, you get 15. 15 plus 7, you get 22. 22 plus 7, you get 29. So here the pattern is add 7. Or if in terms of words, it is the pattern for the sequence is number. So for this subtopic, there's another more interesting way of describing a pattern, which is by using algebraic expression. So now we are back to example 1. We're using the same set of numbers, the number sequence here. So 1 plus 4, you get 5. 5 plus 4, you get 9. 9 plus 4, you get 13. The pattern is adding 4. How are we going to describe this pattern in the form of algebraic expressions? So before that, let me show you examples. I start off with 1, then I have 5, I have 9, and a 13. Okay, so I start with 5 first. As you can see here, from the pattern here, 5 is actually from 1 plus 4. So 5 is actually 1 plus 4. And if we look at the next term, number 9 here, 9, how do you get the 9? By adding 5 and 4. So 9 is adding 5 to 4. This 5, which is this 5, actually equals to 1 plus 4, right? Hence, we can substitute the 5 by using 1 plus 4. So, what do I mean? I erase this. I'm substituting the 5 with 1 plus 4 because 5 equals to 1 plus 4. Hence, I get this. Let's double check the answer. 1 plus 4, you get 9. Okay, we'll come back to this in a while. Now we continue. 13. We get 13 from 9 plus 4. So 13 is 9 plus 4. And from the previous term, 9 here is actually 1 plus 4, which we are going to use it to substitute into this 9. And hence, now you will get the 9 here becomes 1 plus 4 plus 4 plus 4. You can try to add this, you get 13 as well. I think for most of you, you can already guess if I am to write 14 like this, how should I write it? How many 4s are there? Okay, so I think you can see the pattern here. 1 4, 2 4s, 3 4s. Of course, the next one we have 4 4s. There are 4 of them. For the number 4, there are 4 of them. And for 21, there are 5 of them. Okay. Now we can write all of this in another form. Okay, so I'll give you an example here. Okay, so for this one, this is equals to 1 plus 4. And since there is only 1 4, we can write this as 4 times 1 because 4 times 1 is 4. Then for the second one, we can write 1 plus, okay, this 1 plus here is from here. There are two 4s. So we can write this as 4 times 2 because there are two 4. Then for the next one, there are 3 4, so we can write 1 plus 4 times 3. You can check, 1 plus 4 times 3 is actually still 13. And again, if you can see the pattern here, you can see that we can write the next one without looking at this. We already know it is 4 times 1, 2, 3, so it is 4. And without writing this part, we can write the next term, 21, 1 plus 4 times 5. Don't forget, we still have the first one here, the 1 here. How should we write this? Okay, 1 plus 4 times what? As you can see, the number is decreasing, right? 5, 4, 3, 2, 1. And in order to get 1, we need to multiply this by 0. So 4 times 0. Okay, 4 times 0 is 0, right? So 1 plus 0 is still 1. So now, if we are to describe this pattern by using algebraic expression, we can write all of this by using this 1 plus 4, okay, which is the same for all of the terms here. And what is different here is the running number of 0, 1, 2, 3, 4, 5. This is a running number. You see the number is increasing. So whenever you have running numbers such as this, we use n to replace the running numbers. Okay, so hence we have n for this 4 times n. So we write it as 1 plus 4n. So we can use this expression to represent all of this, including the rest of the terms, including from 21 and so on. But we need to define the n. We need to tell the reader what is n. Okay, so we should write n is equals to 0, 1, 2, 3. So you write 0, comma, 1, comma, 2, comma, dot, triple dots here to imply that the number is continuous. Hence, this is describing the patterns by using algebraic expression. If we want to complete this sentence, the pattern for the number sequence can be expressed as 1 plus 4n, where n equals to 0, 1, 2, and so on. This is the answer. We try example number 2. So now we have the example number 2 is still the same as the previous example number 2, the same set of numbers, just that this time we have to describe it using algebraic expressions. So back to this, just now we used adding 7, right? 1 plus 7 is 8, 8 plus 7 is 15, 15 plus 7 is 22, and so on. We start with this 1, 8, 15, 22, and for 8 is equals to 1 plus 7, so 1 plus 7. And again, 15 is equals to 8 plus 7. So we can write this as 8 plus 7. And 8 is actually 1 plus 7. So we replace the 8 with 1 plus 7 here. So this one, we substitute into the 8 here, we get this. And 22 is equals to 15 plus 7. 15 plus 7. And now we do the same thing here. 15 replaced with 1 plus 7 and 7. You get 15. So 15 is 1 plus 7 plus 7. And I think you know how to write the rest lah. Oh, this is 1 plus 7 plus 7 plus 7. And there are 4 7s. If we continue to write this in the form of 1 plus 7 times 1, because there is 1 7 only, then the second one will be 1 plus 7 times 2, because there are 2 7s. We have 3 7s and 4 7s here, so it becomes 7 times 3, and you can see the pattern is 7 times 4. If we want to continue, we have 7 times 5 and so on. And back to the 1 here again, 1 is equals to 7 times 0. And now we are trying to write this using the algebraic expression. And you can see that all the terms here is 1 plus 7 is constant throughout the terms. So we write 1 plus 7. And for the running numbers here, remember we use n to represent running numbers. So you have n here, 1 plus 7n, where n equals to, so you have to, since we are starting the n with 0 here, so we need to start from 0. Okay, for this part, for some questions, it might not start with 0. Some start with 1, some start with 1, some start with 2. It depends on the situation. So for our case here, we start with 0 here, hence 0, and then 1, 2, 3. So now we look at other examples. Now we are trying to determine the pattern by using the algebraic expression. Means we are doing the same thing here. You may pause the video and try to do it by yourself before you check the answers. So from 2 to 6, it is increasing, so it's either addition or multiplication. So if it is addition, 2 plus 4 you get 6, 6 plus 4 you get 10, 10 plus 4 you get 14, and so on, which is correct. So now if you want to write as what I did just now, we have 2, 6, 10, 14, 18, and so on. And you can see that 6 is actually 2 plus 4. So 6 is 2 plus 4. And then for 10, it is 6 plus 4. 6 plus 4. And of course here the 6 we try to replace with 2 plus 4. And we get 2 plus 4 plus 4. And I think you can see the patterns here, but we try one more. 14 is 10 plus 4. 14 is 10 plus 4. And 10 here equals to 2 plus 4 plus 4. So we can write this as 2 plus 4 plus 4 for 10 plus 4. And now you can see that the pattern is 2 plus 4, because since there is 1 4, there's only one of them, so you times 1. We have 2 4s here, it becomes 2 plus 4 times 2. Then we have 2 plus 4 times 3, because there are 4 3s. And of course the last one here, the 18 here, if you want to write, it becomes 2 plus 4 times 4. And back to the first one here, we have 2 plus 4 times 0. This example is different than the previous one because now we are starting from 2. So it does not always start from the value of 1. It depends on your initial term, the first term. Hence, if you want to write this, so the pattern for the number sequence is 2 plus 4. And then remember, running numbers we replace with n. So 4 times n, where n equals to, so we look at the first value of n, which is 0. Then we have 1 and 2, so we write 0, 1, 2, continue. Okay, this time you may try this. Pause the video. And now you can see that again, this is increasing numbers, so it is either addition or multiplication. So if we take additions, 3 plus 6 is 9. 9 plus 6, you're supposed to get 15, not 27. Hence, this is not the pattern here. We use multiplication. So 3 times 3, you get 9. 9 times 3, you get 27. 27 times 3, you get 81. Hence, this is the pattern here. So how are we going to show this using the algebraic expression? As you can see, previously, all our examples are addition. The patterns are addition. So now, how are we going to write if using multiplication? Okay, so same thing here. 3, 9, 27, 81. 9 equals to 3 times 3. 27 equals to 9 times 3. And since our 9 here equals to 3 times 3, so this 9 can be written as 3 times 3. Yeah, this is 9, right? 9. And next, for 81, 81 equals to 27 times 3. So it's 27 times 3. And again, 27 can be replaced or substitute with 3 times 3 times 3. Hence, 27 is equals to 3 times 3 times 3. And if you have the next number, you will know that there will be 5 of them. 5 of the 3s here. And back to the first one, 3 of course is equals to 3. Okay, so the next thing is for multiplication of the same number. Last year in mathematics form 1, you have learned that when 3 times 3, you can write this as 3 squared. If 3 times 3 times 3, you can write this as 3 cubed. Hence, here you have 4 3, so you can write this as 3 to the power of 4. Now back to the first one here, you can write this as 3 to the power of 1. Okay, remember any number to the power of 1 is always the number itself. A to the power of 1 is A, 5 to the power of 1 is 5. So how are you going to write this? Using algebraic expression. Yeah, as you can see, the 3 is the same for all the terms, hence your algebraic expression is 3. And then here, since it is the running numbers, and remember, running numbers we replace with n, so it's n. And one more thing, you need to define the n. So he says here, where n equals to, look at the first value, it is 1. Okay, so not 0. Be careful here, it must start with 1 here, so it's 1 2 3 dot dot dot. Of course, if you are very good with the numbers here, you can just identify the patterns and write the answers here. This part here is just to show you how you get this, and from here how you get this. So if you try a few more examples, you are very familiar with the work, you don't have to show this part. This is just for your understanding. Okay, so for the next one here, you can see that the numbers are decreasing. So if decreasing, we have to use either minus or division. So we start with by using subtraction here. Okay, so 5 minus what? You get 2. 5 minus 3, you get 2. So we try again. 2 minus 3, we get -1, which is correct here. So means the pattern, when we try one more, -1 minus 3, you get -4. Hence the pattern is -3. Subtract 3 from the previous number. And then if we want to write this out, and then we can write this as 5 here, 2, -1, -4, -7. 2 is equals to 5 minus 3, as stated here. Okay, 5 minus 3, you get 2. Then -1 is 2 minus 3. Okay, 2 minus 3. And the 2 here, you can replace the 2 with 5 minus 3. Since 5 minus 3 is 2. So I take this, 5 minus 3, I substitute here, I get this. And then we try one more. -4 is equals to -1 minus 3. So -1 minus 3. And again, the same thing happens here. -1 can be replaced by 5 minus 3 minus 3. Hence, this is being replaced into the -1 here. You get 5 minus 3 minus 3. And for the next one, I think, yeah, you get the pattern here, which is 5 minus 3 minus 3 minus 3 and minus another 3. So we write this as 5 minus 3. Okay, as you can see, the repeating numbers is the -3 here. So we just write 3 times 1, since there is only 1 3 here. And then we have 5 minus 3 times 2, because there are two -3. And then we have 3 -3, so you have 5 minus 3 times 3. And of course here we have 4 -3. So 5 times -3 times 4, because there are 4 of them. And of course the last one here, we have 5 minus 3 to the times 0. So you see that this is the repeating part. Hence, the pattern for this number sequence is 5 minus 3. And the running numbers, we use n to represent the running numbers and define n. N is starting from 0 here, 1 2, so you have 0 1 2 dot dot dot. And for the last example here, you can see that the numbers increasing. So we find the patterns here by using addition or multiplication. So if we try to use addition, 4 plus 4, you get 8. 8 plus 4, you get 12, which is not 16. Hence, adding 4 is not the pattern, so we have to use multiply. So 4 times what? You get 8 times 2. 2, 8 times 2 you get 16, 16 times 2 you get 32. Hence, multiplying 2 is the pattern here. So again, we write the numbers out here. 8 is equals to 4 times 2. So 8 is 4 times 2. 16 is equals to 8 times 2. 8 times 2. And hence you have the 8 here, and we replace the 8 with 4 times 2. So the 8 here becomes 4 times 2. How about the next one? 32 equals to 16 times 2. 16 times 2. So 16 here, it can be replaced with 4 times 2 times 2. So I'll have 4 times 2 times 2 here. Now you can see the pattern. Yeah, if we have the next value, which is 64, it will be 4 times 2 times 2 times 2 and another 2 here. We start with this. So the 2 is the one which is increasing. The numbers of 2 is increasing, while 4 remains only 1. We write 4, and then we multiply by 2. Multiply by 2. Then, for this part, it will become 4 times 2 times 2. Remember, 2 times 2 is 2 squared. 2 squared. Here, 2 times 2 times 2 becomes 4 times 2 cubed. And then we have 4 times 2 to the power of 4 because there are 4 of them. Then how about the first one? We have 4 times 2 to the power of what? Okay, back to this. You see here the numbers, the powers here. Okay, so actually this is power 1. Even though it is not written, it is power 1 because again, any values to the power of 1 is the value itself. Hence, this is 2 to the power of 1, and the last one here is 2 to the power of 0. Yeah, because 2 to the power of 0 is 1. Any numbers to the power of 0 is always 1. So if this is 1, 4 times 1 you get 4. But we need to write it in this way because we want to show the sequence in this form. Now how are you going to write this? Okay, you see 4 times 2, and then the running numbers is the power here. This is the running numbers, and the running numbers should be written as n, as the running numbers, where n equals to 0, 1, 2, and so on. We are not done here because when you learn Form 3 mathematics later, you can write the 4 here as 2 to the power of 2 times 2 to the power of n. And then for those who already learned Form 3 mathematics indices, you can further simplify this part. It will become 2 to the power of 2 plus n. This is Form 3 mathematics. So you can also write this in this form. After you get the form from here, you can further simplify it to get this. And you are still using the same values for n, okay, where n equals to 0, 1, 2. For those who are still in Form 2, don't worry about this part. You will learn this next year. If you want to double check, because it's not very common for you to see this, if you want to double check, you can try. Okay, 2 plus n. Okay, so the first n is 0 here. 0, you get 2 to the power of 2, which is 4. Hence the 4 here. Then we have 2 plus 1. You get 2 to the power of 3. 2 to the power of 3 is 8. You get this, correct. For the next one, you have 2 plus, here, 2. So you get 2 to the power of 4. 2 to the power of is 16, which is still correct. And you can continue from there. So this video stops here. I'll see you in the next video. Thank you, everyone.